Hi, my name is Jeff Dalgleish. I'm the Chief Technology Officer and one of the founders at data². In today's video, I'm going to show you our platform and the types of solutions that we can build using it. Data right now is very disconnected. There's a lot of data out there in the world, but unfortunately all of it is connected to other parts of the data. So what we specialize in is taking data sets, connecting them together. We use knowledge graphs to connect them. And then we pass these knowledge graphs to large language models to reason over it and to solve problems. Being able to make quick, smart decisions is really important. Things are changing so quickly, new information's coming in constantly, and being able to stay on top of that and to be able to reason over it is becoming more and more important. The problem is you're buried in data. There's so much data out there. Just keeping track of it's almost impossible. People are short on staff and mentally stretched because of that. And sometimes this can cause decision making to grind to a halt in many organizations. So in this example, I'm going to create a use case it's fictional. The data in it's real, but it's a sort of an example use case. But the idea here is there's a data set we got access to. It's public data. This isn't anything secret. It's the US government AI use cases that they've published. There's 710 of them over the 28 departments. And what I'm going to do in this project, each one of these use cases is basically a project description of what they want. So I'm going to take that information, I'm going to load it into a graph. I'll show you how we do that. And then I'm going to have the AI answer a bunch of questions about each project, and it'll store those answers back in the graph, and we're going to be able to generate project plans for each one of these projects. So it's sort of a quick way to take a bunch of information, bring it into a graph, understand what it's about, and then let's make some decisions around it. So one of the things we're going to ask the AI is, which project should we be doing as a company? Based on there's 710 of these out there, and we need to pick the few that we're going to be good at, that are going to match our skill sets. And we're going to want to be able to get an elevated starting point on each one of these projects. So maybe a project plan, what kind of staffing are we going to need, and maybe some project complexity measures. So I'll show you how to do all that, all without writing any code. So let's take a quick look at the data. It's always important to start with data. This is what it looks like when we downloaded it. It's a CSV file, and it's got really just a fairly simple description. The name of the use case, which department it's part of. There's a summary there. There's 710 of these. I'm just showing a small example, but this is sort of a deeper dive into one of them. This is for the Customs and Border Protection. I picked it randomly. But the title on this one is AI Curated Synthetic Data. And if you take a look at the summary, essentially what they're looking for is an application that can use computer vision to identify things that may be being brought in through the borders that they don't want. So it's an anomaly detection type of algorithm, not super complicated, but it's something that, an AI should be able to take a look at this and be able to develop what are the kind of skills that we need. So the way we're going to do that is we're going to load this information in, and then we're going to load some questions in. So the questions we're going to load in are what types of skills would be needed to do this use case? On a scale of 1 to 10, how difficult would it be to do this use case? And then we wanted to develop a project plan. And then we're going to give it a little bit of information. We're not going crazy here, but we're just saying we want an introduction, project objectives, and a detailed scope of work, maybe a system module breakdown, and project risks. And then because we're a graph-based company, we wanted to think about and give us some suggestions on how a graph-based solution could be used for this type of use case, and what are the types of evidence that we'll need to collect on how they could actually build this into a graph-based solution. So what's going to happen, we're going to ingest the data, then we're going to enrich it, and we're going to build a graph. It'll look something like this. This is just an example of it, and just to give you a feel for it, each one of these pink dots here are different projects. And then for each one of these projects, we've connected it up to what kind of machine learning algorithms are going to be needed to do that project. So the AI will come up with this list and be able to connect these things together. We've also got in here things that we're good at doing. We're good at natural language processing, and because we have a strong background in oil and gas, I put the word casing in here. We're also good at understanding casing, knowing what it's about. The AI will look at this and come up with some suggestions of things that we might be good at. And the end result's going to look like this. This is the sustained casing pressure. So in the top, you can see you've got a little description of the project. This is what they wrote. This is not what we created. But every one of these things, the project skills needed, the project plan, and the project complexity, these are all things that the AI generated. And I'll show you how we do that. And then we're going to go in and we're going to ask it a question. This is just, I'm showing you the end before I show you how we get there, just to sort of get this in the right order. So we're going to ask it the question, what are the best use cases suited for a company that knows a lot about natural language processing in oil and gas and knowledge graphs? So it comes back with an answer, and we'll take a look at this in more detail later, but really what it's doing is it's identifying projects in the graph that have some relationships to things we're good at doing as a company. So what it came back with is a list of projects that are very well suited for companies that do know a lot about oil wells and natural language processing and artificial intelligence. Let's walk through the process. So there's really 4 stages in any one of the projects that we do. The first is to connect the information, which I mentioned at the beginning. In this project, there's not a lot of connecting going on, but there is some. We're essentially taking that use case data set and we're loading it in, and then we're going to go into each use case and we're going to extract from each use case what are the types of AI techniques that they're looking to use in that project. And then we're going to enrich it. And this is where we do the question asking. That's one element of enriching. We've got, I think, 5 ways to do it. But the first and most important probably right now is using generative AI to ask questions about the project. The generative AI will ask a question like, what are the skills we need to do this project? And then it'll take that answer that the AI comes back with and store that back in the graph connected to the project that it's part of. And then this is where it gets really interesting. Then what we're going to do is we're going to start reasoning over this graph. We're going to ask it questions. We're going to get an AI to answer questions that we come up with in real time based on this knowledge graph that we've provided. So a normal LLM isn't going to be able to answer questions about very specific data, but these types of generative AI applications that use knowledge graphs, and we personally use a knowledge graph called Neo4j. It's an amazing back-end graph, and even on our visualize, which is our last component, I'll show you how we can build front ends very, very quickly using some of the tooling that's already there to go and build simple user interfaces to get these projects up and running quickly, and it looks great. All right, so let's jump into it. So we're going to start off with connect. So we're going to introduce an idea of a body of knowledge. So whenever we bring information into our system, we put it into this body of knowledge. And the body of knowledge contains evidence about the problem, maybe some entities about the problem, some patterns you may want to extract from the data set, and questions you want to ask about the data set, and some context about it. So there's about 5 things, and I'll show you what that looks like. So then what we'll do is we'll load that data directly into our graph, and we call it the ICE graph. It's an intelligence graph. And we have a tool called the Arctic encoder, which takes all of the body of knowledge and it encodes that in such a way that it can populate it into a graph. So we wanted to make this process quick and easy, so you don't have to know much about graphs and how to go and do all of this internal stuff. You really just have to use our Arctic encoder, and it'll load the graph for you. The next step we're going to go into is enriching. So once we've got the initial graph built, well, all of the evidence that we're looking at is going to be in the graph, and then we're going to go and extract entities from it, and then we're going to ask questions. We're going to use our generative AI question answering enricher to enrich it. And that's all we're going to do with this one. We're not really going to get into the relationship enricher and some of the other functionality. I want to keep it pretty simple. But then basically what we do is we run the enricher, it enriches our data set, and at that point we can start reasoning. We can actually start asking questions about the data set. And the results are going to get stored in the intelligence graph. The questions themselves get stored in a separate knowledge graph, and there's a lot of reasons we do this, but at a high level, the main reason is we want to make sure the explainability, the ability for when our AI comes up with an answer, we want to be able to explain how and why it came to that answer. If it's making a recommendation, it's extremely important to know why it made that recommendation. And we keep those data sets completely separate for a couple of reasons. One is sometimes we want to populate our original data set with AI answers. So we want to keep it separate initially so we know what the AI created and what was actually source data. And then finally, the last part is just a user interface. So we're going to put a user interface around this whole thing so that everybody can use it at the same time. And the problems you can use with this type of solution are as many as you can dream up. The one we're going to look at today is basically building a project proposal system. We've done other ones where we do oil and gas systems, or we look at wells and we try to figure out what happened with a particular well. There's a whole bunch of different use cases that are possible with this. All right, well, let's jump in and take a look at how we do this. All right, let's try to build this AI. So in order to get started, we have what we call a body of knowledge. And a body of knowledge is everything and all of the context that we want to be able to give the artificial intelligence that we're building so that it can make decisions and reason over this body of knowledge. And we've tried to keep it very simple. We've broken it into 5 folders. So you just need to copy files into these folders, and the AI will pick that up and use that when it's thinking and reasoning. So I'll just go through them quickly. Context is context about the situation. It allows us to set information about how the large language model is going to reason over this data. So we could give it specific instructions, and we store that in a file here. And we can change that depending on what we want the AI to do. There's entities, and these are things that we're going to extract from the evidence. So maybe we'll start with evidence first. If I open evidence and we take a look at this human intelligence use cases, these are basically the use cases that we're going to reason over. So this is that big file of all of the different projects that we're going to be looking at. And you can see at the top there's a set of column names, so use case ID. But you can see some of these look a little bit different. So who-department.code. What this is doing is it's mapping how we want this element in our CSV file to map to the graph. And we'll get into that in another video, but suffice to say for now, when you use this format, you're able to create different entities within the graph. So we're creating an entity here called department, where we're going to break it away from this piece of evidence around just the description of the project. So this is the evidence file. And this is what we're going to be ingesting initially. This is the evidence for the project we're working on. So if I go back to my folder structure, there's a couple of other folders in here we haven't really taken a look at yet. There's an entities folder, which we'll cover in about 2 or 3 minutes. The questions folder will cover that as well, but this is where we store questions we want to ask about the evidence, and then a support folder. But let's first get the system running, and let's get the evidence loaded into it. So here we are on a terminal window. We're a beta version right now, so a lot of what you'll see will be command line driven. First, everything's in a Docker container, so we can spin up our Docker container. It's called reView, and it'll basically get the container up and running, and it'll launch a couple of other applications that we can use to do the reasoning with. Okay, so that's up and running. So the first thing that we're going to do in here is we want to ingest the data into the graph. So to do that, there's a simple command, Python 3, and then we give it the name of the file, and we simply run that. And what that's going to do is going to look through the folder structure that we gave it, and it'll process the file that's in there, which was in that evidence folder. If you look back here, it's going to process everything in the evidence folder. So there can be thousands of files in here, or just one. In this case, it's just a simple file. Some projects we do have hundreds and hundreds of files here, but this is a simple use case. So it's run, and I'll just show you what effect that actually had on the system. I'm going to go over to something called Neo4j Bloom, which is a way to look at evidence and nodes in the graph. So I want to see what evidence we have in the graph, and this is our use cases. So I'll just put use case here. So we'll take a look at our use cases. And we want to see, let's type that correctly, and we want to see how these use cases connect to, say, different departments. So there we go, department, and press enter. So here's a quick look at a small part of the graph, and we can zoom in here so we can see here's some cybersecurity. This is how we separated the department from those sources of data. And this graph's not finished yet, but this is just sort of the first pass. I want to show you what it looks like. So here's the evidence. If we double click on one of these pieces of evidence, you can see the department, the name, the summary, the text evidence, and that's it, TRL level and the use case ID. So this is basically what was in the spreadsheet with the addition of this breakout of this department name. These can get much more complicated, but they can get much more connected, but in this simple use case, we just keep it simple. The next step we want to do, now that we have this initial graph built out, we want to be able to go in and enrich it. So we want to understand for every one of these pieces of evidence, or each one of these use cases, what are the types of AI they're thinking of using for it? And then we want to ask a bunch of questions about it. So to do that, we're going to pop back over to the folder structure so I can explain how this is working. So if you look in the entities folder, there's something called AI type here. And AI type, this is an example. So we're giving it a known list or controlled vocabulary. We're sending it a list of terms and synonyms for those terms. And then what we want the algorithm to do is we want it to go through and look through every one of these pieces of evidence, everything in the folder structure over here. Actually, here it was. Everything in here, we wanted to index this information against all of these terms. And when it finds a match, we want to be able to create a link in the graph to show how that works. Okay, let's take a look at the last folder now, this folder called questions. So inside the questions folder, there's really supposed to just be one file called questions.json. I've got a backup in here as well. But let's take a look at this questions.json file. So this file is how we ask questions of the evidence and have those answers stored back in the graph. So for example, here, we have, we'll start with this one here. We'll skip this one for now, but this top one, what types of skills would be needed to do this use case? So that's a question, and we want to have that question answered by the Claude model, which is a large language model that runs on AWS. It's a Anthropic model. And then we've got on a scale of 1 to 10. So these are the questions we came up with before. Develop the project plan. So this is where we give it the questions. There's a couple of other things in here. Extract the entities. This is where we give it that path to the entities folder, where we index all the known entities from it. And then we can there's a third one here, ask AI entities. We can actually have the AI do topic modeling. So we can ask it to go and extract any organization names that are mentioned in the use case, and it'll store that back in the graph, and it'll store it. It'll use Claude again for this. So we're using the Claude model right now, but really there's just a small set of questions. So like, how would you use a graph solution for this use case? Develop the project plan on a scale of 1 to 10. How hard is it to do? And what are the types of skills needed? So this is how we control what questions we ask and what entities we want to index. I won't go into all of the details here, but just give you an idea how this works. This is, again, something that we're going to put a user interface around to make it much easier to do. But for now, it works just fine by editing this one file. Okay, so let's give it a run. We'll go back to the actual application, and here is where we can now enrich the data set. Okay, we're back at our trusty terminal window, and we're going to run our next command, which is going to be the extract, the entity extract agent. This is really the enrich agent. So if we run this, it's going to go and it's going to connect to the graph, and it's going to start asking so you see how it says at the bottom, asking AI Q&A question, what types of skills would be needed to do this use case? So what it's doing right now is it's taking every one of the nodes in the graph, that's a use case, and it's taking the text about that graph, and it's saying to the AI what types of skills would be needed to do this use case, and then it gives it the use case. The AI comes up with an answer, returns it back to the application, and the application stores that back in the node that contains that use case in the graph. I'm going to pause it here because this will take a few minutes to run, and we'll be back. All right, and we're back. Just enough time to make a coffee and have the AI answer all of our questions that we asked it. So you can see in the interface that it went and asked all of those questions. What are the skills on a scale of 1 to 10? Develop a project plan, and how could a graph be used? So let's see the answers it came back with, and where it's stored. So if we're back in our graph, we're looking at 2 nodes. I've zoomed into just 2 of them now to keep it simpler, but we're looking at the USGS, which is the U.S. Geological Survey, and it looks like there's 5 use cases for that one. And then there's the Bureau of Safety and Environmental Enforcement. And there's this one here called Well Risk. So I can double click on that to see how things have changed. So last time, you remember, we had department and name, but this project complexity is new. So this is what the large language model came back with for this particular project. And let's just remind ourselves what it is. I'll scroll down a little bit. There's something called text evidence where we store the project description. So the project description for this one is NASA's Advanced Supercomputing Division will be utilized the work performed in the sustained casing pressure research to explore the development of machine learning models to identify various precursors to risk factors for wells. By identifying these risk factors, it will help the BSEE inform engineers of potential problems with wells during the various stages of development. So that's the description. And we've asked it those questions, and it came back with some answers. So the project complexity, it's giving it a 7 out of 10. And then it talks about the key reasons why it believes it's a 7 out of 10. It mentions the types of maybe some techniques you would use to do it. If we scroll down a bit more, there's a project graph. So this is how a graph could be used to solve this problem. So looking at sensor data on the wells, pressure and temperature, looking at operational logs, so maybe drilling morning reports. So a lot of these things make a lot of sense. Like for an oil and gas application, you are going to want to look at all the different basic data sets you have around the casing so you can understand what's going on with it. And then just come up with a project plan, which we asked, and I won't go and read this whole thing. Feel free to stop scrolling or stop the video and take a look at it if you want. There's also project skills needed. So this is sort of an assessment of what are the types of skills people will need in order to do these projects. And it's coming back with some ideas in terms of techniques and applications you're going to need to know how to use. And that's really the first step of it. So it's gone through and it's enriched this. What we started with was just a description of a project, and now we have examples of how we're going in and enriching these projects based on the questions we ask it. Now, there's a couple other things we can do with this graph. Like we mentioned before, we were enriching it based on the types of machine learning algorithms that we're using. So we can take a look at the use cases, and let's just add, I think it's called AI type. So the AI type here is how we enriched the application to look at what are the different types of AI that are going to be needed to do these use cases. So what it's done, here's our BSEE. So these are the different projects. And then that well-risk one that we're looking at, it is claiming that should be looking at maybe some machine learning algorithms and some deep learning algorithms. You can see here, we've got another use case here. I'm not sure what it is. If we double click on it, we can see. But this is kind of clunky. In order to interact with the graph, you're looking at these nodes and these objects. So in the next section, we're going to show how to take this and actually move it into a user interface front end, where you can explore each one of these use cases in a much more convenient way. Okay, let's take a look at this user interface. So right now, this is where we basically are running our different graphs from. Right now, we're running this GovAI review graph. You can see that it's active. So what I'm going to do is I'm going to open up another little application called NeoDash, which is a great little application for very quickly building front ends for graph applications, which is what we've just built. So it starts off and asks, what do you want to do? We'll just go with the dashboard we've already created. I won't start right at the beginning. I'll start with something we've already built. So we connect to the database we're on, and here's a look at the graph. So this is just what we were looking at in the last screen, but now we're looking at it inside a brand new front end. So I've put a title on it. We can edit the title. There's all the usual interface things you can do. And then we've got 3 tabs here that I'll just walk through. The first one's the Analyst tab. It really is just a high-level look at what's in the graph. So you can look at different departments. You can click on the USGS. I haven't loaded everything in this use case. It's just 2 of them to make it simple. But there's basic interactions. You can double-click. You can look at, say, the project plan here. So you can interact with nodes directly, and this is pretty nice. But then we've also got this one called the Project Proposal Builder. And this is where I've sort of pulled it out a little bit further. We've got the list of the projects here. So let's go back to that well-risk project. I'll just click on it. And this is a much easier way for people to consume it. You can imagine this being a PDF document. Like there's a whole bunch of different ways you can present the information to the end user. This is a pretty simple one though. We put the project description up here, that NASA supercomputer project where we're looking at risk around the casing. And then it breaks out the project skills and the project plan and the complexity. So, this is just a little bit easier to look at it. There's also the project graph in here, information down near the bottom, the graph ideas. So this is kind of a way just to pull this information back together. So this is how you started a spreadsheet, you ingest the information into a graph, you enrich the graph with a variety of question asking techniques and pulling out entities from the text. And this allows us to build these project plans and these project proposals. Now, the last thing we haven't looked at yet is what we call the reasoner. And this is where it starts to get quite interesting. This is where you can ask questions not of the individual pieces of evidence, but of the entire body of knowledge. So let's say, for example, we want to ask a question to the AI, what would be good projects for a company that is good at knowledge graphs and oil and gas projects. Let's say and natural language processing. Let's use NLP. And maybe I'll spell and correctly. And so that's the question we'll ask. Now what it's going to do is it's going to look at the entire body of knowledge, and it's going to ask this question not of a piece of evidence, but of everything in the graph. So this should come back with an assessment of what are the projects of all of these projects that we've got loaded in there, which are the ones that are most suited for companies like us. And it's very likely going to come back with projects in the oil and gas space that have to do with artificial intelligence, with natural language processing, and knowledge graphs. We've done another use case where we did a look at intelligence data, and there'll be a link to that at the end of this video. But what that does is it basically shows exactly what we've done here, but a different domain. In that case, we're using information from a intelligence use case that we got from the Patrick Henry College. And it's really looking at a terrorist situation where they're trying to understand who, here we go, let's come back. Who is responsible for killing of an informant. But feel free to go and take a look at that video. It sort of shows another way to look at this, and there's some very interesting reasoning it can do there. It can reason over a body of knowledge from the intelligence community to figure out who the actors are in this scenario and trying to figure out who done it kind of problems. But let's take a look at this one here. So it came back. So, okay, great. The sustained casing pressure came back. And then it gives us some details on why it chose that one. It came back with a well activity report classification. So this is the one that's actually near and dear to my heart. Well activity reports for drilling comments, looking at that information. I've enjoyed it over the years. But this is well risk identification and corrosion detection from images. So, okay, those are pretty good. And then what it does is it basically, so this is just question answering. We could ask it any question here, like what projects are, what's the U.S. government trying to accomplish with these projects? Like there's anything you can think of. This is sort of a back and forth. You can use it for brainstorming and a whole variety of things. One of the things we do is whenever it's quoting things in a graph, we mention what node it's coming from. So when it comes up with a summary and it's reasoning over the body of knowledge, we want it to be quoting nodes. So whenever we want to be like, well, why did it come up with that answer? We want to be able to go back to node 20 and take a look at it. So really, this is what the reasoner is doing, is it's taking that body of knowledge, allowing you to ask questions about it, and you're asking questions about the enriched information as well. That whole graph is being patched to the language model. So this is really where things are going to start getting interesting as we start bringing in and using generative AI into our businesses. This is where engineers and people that are using these applications will be asking questions. Like, what questions will they ask? And that's what the language models will be replying with. And they're going to be able to have to trust them. This is why we're quoting node numbers. That's pretty much it for the overview. Thanks for watching and getting to this point in the video. Thank you very much. And if you want to take a look at us online, our website is data2.ai, and of course you could always find us on LinkedIn. Thank you very much.